Okay, Euclidean geometry time, and they are saying in the diagram ABCD. ABCD is a cyclic quadrilateral. Now, if now they are saying ABCD is a cyclic quadrilateral, we need to think about two things. What is a cyclic quad? And also the theorems that falls under cyclic quadrilateral. So a cyclic quad is a type of quadrilateral with vertices that lies on the circumference. Okay, as you can see, here is vertex number 1, it lies on the circumference. Number 2 lies on the circumference. Number 3, it lies on the circumference. And number 4, it also lies on the circumference. So all the vertices of this quadrilateral lies on the or rather lie on the circumference. That is a cyclic quadrilateral, and we can all agree that ABCD is a cyclic quadrilateral. Then after that, we need to think about three theorems that falls or rather that fall under cyclic quadrilateral. Three theorems. Okay, then after knowing or rather identifying those three theorems, we can therefore apply them on the given sketch. So the first theorem that falls under cyclic quadrilateral says opposite angles of cyclic quad are supplementary. Opposite angles of cyclic quadrilateral are supplementary. What does that mean? It means the angles that are opposite to each other in cyclic quad, the sum of those two angles is equal to 180 degrees. So let's identify the angles that are opposite to each other in our sketch. Angle A, the whole angle A, that is A1 and A2, plus C, angle C, C2 and C3 in this case, is equal to 180 degrees. Why? Because of the theorem that says opposite angles of a cyclic quadrilateral are supplementary. All right. Again, angle D plus angle B is equal to 180 degrees. Why? Because angle D is opposite to angle B, and therefore the theorem says opposite angles of cyclic quadrilateral are supplementary. All right, opposite angles of only cyclic quadrilateral, not any other quadrilateral. So in this case, angle D plus angle B is equals to 180 degrees. Then we can move to the next theorem, which says the exterior angle. What is the exterior angle? That is angle that is outside. Exterior means outside. So this theorem says the exterior angle of a cyclic quad is equals to the interior. Interior means inside. So this angle that is outside our cyclic quad is going to be equals to the interior opposite angle of a cyclic quad. So we've got the angle that is outside of a cyclic quad, and we also have the interior angle. So the exterior angle, that angle that is outside the cyclic quad, is going to be equals to the angle that is inside the cyclic quad. But please note that that angle that is outside is opposite to that interior angle. If that's the case, then those two angles are equal. So in this case, let's identify the exterior angle. Exterior angle C1. which is equals to 86 degrees. It's outside our cyclic quadrilateral, which is ABCD. Now this C1 is going to be equals to which angle? Please identify the angle that is opposite to C1, but it's inside the cyclic quad. As you can see, A1 and A2, the whole angle A is definitely opposite to C1. Therefore, angle A1 plus angle A2 is equal to angle C1 because of the exterior angle of a cyclic quad. Okay, theorem number 3, it says angles subtended by the same chord or arc are equal, and I hope you can see that we can't apply that angle in this case. Okay, we cannot apply that theorem, rather we cannot apply that theorem in this case. So we can only apply 1 and 2. Therefore, we can carry on with our statement, and they are saying BC is produced to E, AC is drawn, angle A1 is half of angle B. Angle A1 is half of angle B. That's very important. And they are saying angle A2 is equals to 46 degrees, and angle C1 is equal to 86 degrees. Now, with the whole analysis or with the whole interpretation, we can therefore answer the questions. All right, let me erase here so that we can answer the questions. All right, so let's answer the questions. Now, the very first question, 9.1, is saying calculate with a reason the value of A1. The value of A1. We just said angle A1 plus angle A2 is equals to angle C1. Let's write it down. Angle A1 plus angle A2 is equals to angle C1 with a reason. This is Euclidean geometry. Remember, we said the interior, or rather the exterior angle of a cyclic quad is going to be equals to the interior opposite angle. Okay, so you will say exterior angle of a cyclic quad. You don't have to write the whole statement of theorem. Okay, in this case we want the value of A1. A2, I think we are given the value of A2 here. Right, let's write it here again, or rather let's write it here. We said A1 plus A2 is equals to C1 because of the exterior angle of a cyclic quad. Right, therefore we are looking for angle A1. We are given angle A2 46 degrees. Okay, so plus 46 degrees, and we are also given angle C1, which is 86 degrees. 86 degrees, and therefore you can, or we can transpose 46 degrees to the other side, and therefore angle A1 is definitely equals to 86 minus 46. I think that's 40. Yes, 40 degrees. That is angle A1. And remember, this angle A1 is half of angle B. That's that's what they said to us, yes, in their statement. Okay. 9.2, hence. Now they're saying hence. It means whatever that you did in the previous question is also applicable in this question. Hence, prove that AD, the length of AD, is equals to DC. We are trying to prove that this length or this side is equals to this side. Now, to prove, you will need to do the opposite of what you know. Let's say that we know that angle AD is equals to angle DC. If two adjacent sides are equal, then what is going to happen with, or what do you know about the base angles, the angles that are opposite to those two adjacent sides? The base angles will also be equal. In this case, angle A1 will also be equal to angle C2. All right, angle A1 will be equals to angle C2. But that's what we know, only if two adjacent sides are equal. In this case, we do not know that a length of AD is equals to the length of DC. That's what we are trying to prove. So in order for us to prove that AD is equals to DC, we need to prove that angle A1 is equals to angle C2. And we already know the size of angle A1, which is 40 degrees. So what are we going to look for? We are going to try and calculate C2. If C2 is equals to A1, then the length of AD will be equals to the length of DC. That's why I'm saying, to prove something, you need to do the opposite of what you know. So now, how can we try to find C2? They said angle A1 is half of B, angle B. So let's try to find the size of angle B. Okay, so when you divide by half on both sides, angle B is definitely equals to 80 degrees, right? Yes, angle B is definitely equals to 80 degrees. With our analysis, we said angle B plus angle D will be equals to 180 degrees because of opposite angles of a cyclic quad are supplementary. That's what we said initially. So let's do the calculations. Angle D plus angle B is equals to 180 degrees. Why? Opposite angles of a cyclic quad. In this case, we are looking for angle D. We calculated angle B as 80 degrees. So when we transpose 180 degrees minus 80 degrees, and this is going to give us 80 degrees, or in fact 180 degrees minus 80 degrees, that is 100. So now in triangle ADC, we have two known angles, angle D, which is 100 degrees, and angle A1, which is 40 degrees. What are we looking for? C2. How can we try to find C2? Sum of angles of a triangle, which says that all angles in a triangle sum up to 180 degrees. So angle A1 plus D plus angle D plus angle C2 will be equals to 180 degrees. Let's do that. Angle A1 plus angle D plus angle C2 will be equal to 180 degrees. Reason, sum of angles of a triangle. A1 40 degrees, right? And then angle D 100 degrees plus angle C2, which is this will all be equals to 180 degrees. Yes, 40 degrees plus 100 degrees, that is 140 degrees, plus C2 is equals to 180 degrees. And take 140 degrees to the other side, it becomes negative. Therefore 180 degrees minus 140 degrees, our C2 is definitely equals to 40 degrees. So can you see A1 is equals to C2, therefore angle A1 is equals to C2. Both of them, they are equals to 40 degrees. And remember, we said if those two base angles are equal, then the two adjacent sides will also be equal. That's the opposite of what we know if two adjacent sides are equal. So AD is equals to DC. That's what we were required to prove, right? Yes. Why? Okay, this is because of two opposite angles equals to two. Remember when we are saying, let's say that we know that AD is equals to DC. Let's say for instance that we know that AD is equals to DC, and then we conclude that angle A1 is equals to angle C2. The reason will be angles opposite equal sides. Okay, so for this one we will say opposite sides equal angles. Opposite sides equal angles, and that's the your 4 marks. Yes, that's your 4 marks 9.2.